Hello guys, today we are going to discuss about two-stroke engine. Which is more efficient, two-stroke engine or four-stroke engine? Is there any two-stroke engine in a car? What is the problem with two-stroke engine? So, without wasting further time, let's get started.
Hello everyone, I will explain the uh, assignment 3 question 1, which is more efficient, the 4-stroke or the 2-stroke engine and why. In terms of fuel efficiency, the 4-stroke engine is more efficient than the 2-stroke engine. What makes the 2-stroke engine is less efficient? There's the three reasons. The first one is scavenging is not stable, the second is the lubrication system, and the last one is the wastage of fuel in 2-stroke engine. The common problem in two-stroke engine is the scavenging is not stable. Scavenging is a process of replacing the exhaust gas in cylinder with the fresh charge, but mostly the two-stroke engine will undergo incomplete scavenging or over-scavenging. This will cause the dilution of charge, then take place and result in poor efficiency. The exhaust gas in two-stroke engine will often get trapped inside the combustion chamber and cause improper combustion. This makes it result in a poor thermal efficiency. So the fresh charge is impure and they cannot achieve the maximum power. The second one is the lubrication system. The two-stroke engine is designed to burn the oil. The lubricating oil in two-stroke engine is mixed with the fuel. So if you continue to burn the lubricant oil, so the component in the two-stroke engine will result in greater wear and tear due to the insufficient of lubricant and finally result in lower mechanical efficiency. The last one is the wastage of fuel. In two-stroke engine, there is nothing called WAF. So the exhaust gas will come out from a place which called exhaust port. So when the combustion is take place, the fresh charge which is going to undergo combustion will pass directly to the exhaust port. So it will not undergo combustion. It will make the fuel is wasted because it does not undergo any process to produce the power. This will cause the fuel consumption per horsepower is compared higher compared to the four-stroke engine. That's all for my part. Thank you.
As you can see, this is question number 2. What is the range of the engine efficiency for two-stroke engine? The range of the engine efficiency for two-stroke engine is around 47.2% up to 50% for thermal. For two-stroke engine, the working cycle is completed in two strokes of piston or one revolution of the crankshaft, which gives twice the number of power than the four-stroke cycle engine at the same speed. Why you don't see two-stroke engine in car? This is because the two-stroke engine would burn a gallon every 1000 miles, which very costly. For your information, the two-stroke engine's oil is very expensive. What a problem with two-stroke engine? The two-stroke engines have been stopped even in motorcycles due to the pollution effects of the effluents emitted by it into the environment, which are CO2, NOx, SOx, and many more. This has caused two-stroke engines not pass emission tests for vehicles on the road. Because of the way the engine is built, some of the air or fuel leaks out of the chamber through the exhaust port, which is why any two-stroke outboard motor has a small thin film or sheen of oil surrounding it, and this leaking oil is a big nightmare for the environment. This is why two-stroke engines are only utilized in applications where the motor is not used frequently and a high power to weight ratio is required. Other than that, engines that run on two strokes do not last nearly as long as engines that run on four strokes. Due to the lack of a spread lubricating system, the parts of two-stroke engine wear out much more quickly. That's all. Thank you.
So good day everyone, my name is Noizati Shara and today I'll be talking about the question 3, the 3 types of two-stroke engine. So the engines that I'll be discussing for today is rotary inlet valve, reed inlet valve, and last but not least, we'll be talking about piston control inlet port. So firstly, I'll be talking about the piston control inlet port, which is the simplest and most commonly used design used in a small two-stroke engine. So the valve or ports control the timing of airflow into the cylinder, and in a two-stroke engine, the piston covers and uncovers the ports, similar to the video shown here. So where in compression, stroke inlet port opens, allowing the air-fuel mixture to enter the chamber, and when the piston moves outward, the complex mixture will be ignited by the spark plug to produce a power for the engine. Next, we'll be talking about the rotary inlet valve. So rotary inlet valve is in the form of a flat disc, or also known as a disc valve. Is commonly used in motor engines, where the arrangement helps to prevent reverse flow back into the intake port during the compression stroke. So this is a short video on how the inlet works. So the hole will be covered and uncovered by the disc as it moves around. So this is why one of the advantage of a rotary disc is that it enables the two-stroke engine intake timing to be asymmetrical, which is not possible with a piston port type of engine. So rotary valve engine can be tailored to deliver power over a wider speed range or a higher power over a narrower speed range, rather than using a piston port a reed valve engine. So speaking of reed valve engine, inlet valve, now I'll be talking about this. So it is also known as a one-way valve, and it is a simple but highly effective form of check valve commonly fitted in the intake tract of the piston control port. The inlet allows asymmetric intake of the fuel charge, improving power and economy while widening the power band. So this is an example of the reed inlet valve, where the reed will be fitted into a piston control port, and it will only allow a one-way flow. So the reed valve controls the fuel air mixture emitted to the cylinder, and reed valve in a two-stroke engine have been placed in the intake ports and also controls the intake to the crankshaft space, as shown in the video right here. And that is all for my presentation on the question 3. Thank you.